what exactly rotation and particle dynamics is. So to understand that, we should know what is a rigid body. So rigid body is something, let's say if I take a body like this, whatever you do to this body, Frederick, the distance between any two particle will remain same. That body is rigid body. Of course, it's very hard, no molding and all. But if you take any 2 points and you do whatever, like you break or like it will never break. First of all, you try to apply force in any direction, you try to make it move, you try to rotate it. The distance between them will never change between 2 points. Okay, that is what we called as a rigid body. Then we have a three types of motion. One is the translation motion. Second is the combination of translation and rotation. And third is the rotation motion. So anything that moves like this in a linear x-axis or y-axis or z-axis, we call as the translatory motion. We called as translatory motion. Okay. Anything that only rotates, we called as the rotation motion. So this is the rotation for it now. This is only rotation. This is only translation. So something can rotate and move. That type of motion can also take place. You're understanding, right? Yeah. One is like this. This is translation. If I rotate this pen, this is only rotation. Something can rotate and move like this. That is a translation plus rotation, which we also called as in one sort of that motion is called as a rolling motion, right? Anything rolls is translation plus rotation. Translation, each particle of body has same displacement. Rotation motion, each particle is in a circular motion. So let's say if you take this particle A is moving in a circle. If you take another particle B, that is also moving in a circle. Okay, so that is basically a rotation motion, more standard definition. Example of rotatory motion, ceiling fan, or if you open a door, that is also a rotation, which is hinged from one point. Okay. What is the translation motion? What is the translatory motion? So if you see something like this, let's say, is it moving? Stationary. That is trans-rotatory motion. So it's rotating as well as it's moving. So that is translation plus rotation motion. Is that clear to you guys? Say yes if it is clear. Okay. Then to understand these things in detail, first quantity we should know is moment of inertia. Okay. When we were in grade 9, we were talking about something called as inertia. Okay. And we have understood that inertia is something that wants to be in its state. Okay. So inertia is related to the state. State can be either rest or in motion. State can be either rest or in motion. Okay. So it can be either rest or motion. Okay. And then we have defined this inertia. Inertia is not equal to mass, but mass is something that tells us information about inertia more correctly. Correct. Mass is very much related to the inertia. If I say I have more inertia, that can also be understood as I have more mass. Okay. When I say more inertia, we can also say more mass. But in terms of rotatory thing, rotatory inertia, when we talk, there's another term which we called as moment of inertia, which we called as the moment of inertia, not the mass. So whenever we were dealing with a translatory motion, we were having MA, right? MV, momentum, half mv square, kinetic energy. Here you will be having I alpha, moment of inertia into acceleration, I omega, moment of inertia into angular velocity as angular momentum. Here I will have half I omega square as kinetic energy. Are you able to correlate what I am saying, guys? That these all things which we have learned, MA, MV and all those part. But here we will be having all different things. Okay, Frederick?
Yes, sir.
Yes, sir. Okay. So moment of inertia of a lot of particle which are associated as a system of a particle, if you need to find out. Let's say I want to find out moment of inertia about this point of mass m1, which is d distance away from this point. So you can say moment of inertia I will be equal to m1d square. That is the formula for moment of inertia. Okay. If you have lot of particle associated in a mass, then you will add all those things. So for this, about this point, m1r1 square plus m2r2 square plus m3r3 square. So that is how also you can find the moment of inertia. Then what is the similarity in moment of inertia and inertia? Inertia depends on mass. Moment of inertia depends on mass and mass distribution. Okay. Like we have seen F is equal to ma. Here you will be having torque is equal to I alpha. Okay. So force acceleration was inversely proportional to the mass. Here angular acceleration will be inversely proportional to the moment of inertia. I want you to calculate MOI of this body which has two mass and distance d by 2. So I can write the total moment of inertia as m into d by 2 the whole square plus m into d by 2 the whole square. So m into d square by 4 into 2. So md square by 2. That's what you got. So how can we do? About the center of mass. And this would be the center of mass axis, I guess. So if I say this is x, so this is d minus x. Correct. So I can write the moment of inertia is equal to m1x square plus m2 into d minus x the whole square. Okay. But if I say where exactly would be the center of mass for this? So center of mass is xcm, which is at this point. Is equal to m1 into x plus m2 into d minus x over m1 plus m2, right? m1x, this is the x coordinate of center of mass, right? m1x into m2 into d minus x. M r square. Now, this point is O. This point is O. This point about the center of mass. If I say this point is origin, guys, let's say this is origin. So I say this coordinate is 0. So I'll get m1x plus m2 into d minus x equal to 0. So m1x equal to minus m2 d plus m2 into x. So value of x comes out to be minus m2 into d. Sorry, you can write value of x is equal to m2d over m2 minus m1. So if I substitute value of x at these two places, so I'll get m1 into x is what? m2d over m2 minus m1, the whole square plus m2 times d minus m2d over m2 minus m1, the whole square. Correct? So if I simplify, we should try that simplification. No, but that is in negative. Yeah, I think that is the correct method which we are doing. What is the meaning of discrete system of mass? When you have a particles like this, like one mass at distance A, second mass 2 at distance A2, you can find using m1 into a square. But what if I ask you to find a continuous distribution of mass? How will you find? So for that, what do? We take a small particle and we integrate it. Okay, we'll not get into that detail of math, but moment of inertia for a continuous system of body comes out as integration dm into r square. Okay. Let's say I need to find the moment of inertia of rod. Okay. Or I need to find moment of inertia of rod about this point or that point. It will have a different values. Moment of inertia for the sphere. Okay. So I want you to note these continuous system of the bodies down. So if you have a disk, moment of inertia about this axis, which is passing through center, is half mr square. Moment of inertia of a ring and passing through this axis is mr square. Moment of inertia of basically a sphere is 2 by 5 mr square, and moment of inertia for this thing, this is for hemisphere. This you can leave it, these two. Right, for the rod passing through the center axis, which is 1 by 12 ml square, and rod about the extreme position is 1 by 3 ml square. So about rod, we will have two moment of inertia. About the center of mass or center point is ml square by 12. Guys, these values you should remember also. And about the extreme point is ml square by 3. For ring, about the diameter is mr square by 2 and something like that. Okay, this we can do torque. Yeah. So the next thing which we have to know is the torque. So what exactly a torque is? Torque is equal to F cross R. Okay. Force into the perpendicular distance. Let's say force is like this and R is like this and making angle theta. So you will write torque is equal to FR sine theta. Okay. That is how you will be finding. You must have seen if you open the door from this point is easier as compared to if you open the door from the near to the hinge point. Okay, the reason behind that is the torque, because when you apply same force F at this point, then you have a larger distance R. So F into large R will give you more torque. If you apply a same force F and to this distance, smaller distance R1, then you will have a comparatively lesser torque. So it's always advisable. That's why if you have seen that the door opener is to the hinge, they never put on the mid or somewhere here. Okay. They put at the extreme point so to have a greater torque.